Let's begin with something that we are already familiar with. Quadratic equations of the form ax square plus bx plus c equal to 0. We can solve it by using the formula x is equal to minus b plus or minus b square minus 4ac under root upon 2a. X is the variable and we can find the value of x. That is what we say by solving the equation. This we are familiar with. Now, while doing this in lower classes, you must have been told something specific about this particular expression which is written under the radical sign. That is b square minus 4ac. This part is called discriminant of the equation discriminant. And if the discriminant is positive, then there are two distinct real roots for this equation. If discriminant is equal to 0, there will be two solutions, but they will be equal solutions. And if this discriminant value is negative, you were told in the lower classes, there is no real solution. No solution. No real number solution. Then, today we are going to see, in case this under root portion is negative, is there any chance of getting a solution? If yes, what is the solution? Let's see. Before we go into that, we need to get familiar with some new notation, that is square root of minus 1. See, in case square root of 16 has to be calculated, yes, the answer is 4. I don't write plus or minus 4, okay? Because I have not put plus or minus here. If it is not put here, we don't put here also. As it is, under root symbol will give you only positive square root. I keep repeating it. Please remember that. Okay, root of 16 is 4, but what are we going to do if it is root of minus 16? Like the discriminant value, if it is negative, what to do? That's what we're going to learn. So, square root of minus 16, for it to be possible, first of all, we need to get familiar with square root of minus 1. Yes, a new definition we are going to see. Square root of minus 1 is not real. No real number can be squared and got minus 1. Not real. But square root of minus 1 is equal to a symbol I, small letter I, which stands for the word iota, which means imaginary. Square root of minus 1 is equal to I, based on which we are going to find the square root of any negative number and little detail about this new concept. So, discriminant is b square minus 4ac. We have already discussed all these part. And if d is greater than 0, less than 0, equal to 0, all these parts we have already discussed. So square root of minus 1 is not a real number. It is denoted as I. Now, let us do one example. Solve the quadratic equation x square plus 6x plus 13 equal to 0. So here a is 1 because coefficient of x square. B is 6, b equal to 6, coefficient of x, and the constant term is c. C is 13. Now let's see how are we going to solve it. I'm going to put it in the formula minus b plus or minus b square minus 4ac under root upon 2a. But while calculating, you notice 6 square minus 52, 36 minus 52 is coming minus 16 inside the under root. Here lies the problem. So what we do is, we will write this minus 16 as root of minus 1 into 16, which is equal to root of minus 1 into root of 16. Root of 16 is 4 and root of minus 1 is I. So we write it as 4I. This is how we are going to solve the quadratic equations where discriminant happens to be negative. So here we go. D is negative. So write minus 16 as minus 1 into 16. So minus 1 into 16 square root is 4I. Now that 4I we are writing plus or minus just because the formula has the plus or minus, okay? This plus or minus is copied, because of which we are getting now two solutions. Which are the two solutions? Minus 6 plus 4I upon 2, minus 6 minus 4I upon 2. These are the two solutions. Yes, we can take a 2 common and then we can cancel. We got two solutions, minus 3 plus 2I or minus 3 minus 2I. Now, these are the two complex solutions. And what is the complex number? Definition comes, the equation has two complex conjugate roots. A number of the form a plus ib is called a complex number. In a complex number, there will be a real part and an imaginary part. This a, this part is called real part. This is the real part. And the other one is called imaginary part. Imaginary part because there is an I in it. That's introduction. Now let's go ahead solving quadratic equations. In your 5.3 exercise, lot of quadratic equations are given. In all of them, you will notice the discriminant will come out to be negative. Because of that, the solutions will be containing the iota I. Therefore, the solutions will be complex numbers. The answers will be complex numbers. Just doing one more. X square plus 3 equal to 0. Yes, this also is a quadratic equation. Here comes a equal to 1. That is the coefficient of x square term. There is no x term. Therefore, we will say b is 0. But there is a constant term, that is c is equal to 3. So a, b, c are being picked up from the equation. Then what to do? We will put in the quadratic equation formula. So minus b plus or minus c, we are putting the value of b as 0 and calculate it and see what's happening. We are getting minus 3 inside the under root sign. So minus 3 square root is taken by using minus 1 square root and 3 square root. Square root of 3 is root 3 only. So 0 by 2, I have separated the 2 also, the denominator also, to both terms. To this also, to this also. That is why we got two terms now. Now what to do? These are the solutions. 0 plus root 3i, 0 minus root 3i. Two solutions are there. Yes. The equation has two complex conjugates. What do you mean by conjugates? Yeah. This is real part is the same. But you see, the imaginary part in one of them is positive, the other one is negative. So, a complex number in the form a plus ib, then its complex conjugate is a minus ib. The sign of the imaginary term is changed, conjugate. You have heard this word conjugate when you did surds in class 9. That is, you will remember if I say rationalize the denominator. So we used to multiply by the conjugate. A similar work here also, complex conjugates. You change the sign of only the imaginary part. So 0 plus root 3i is one solution, 0 minus root 3i is the other solution. Here 0 is the real part, imaginary part is minus root 3i for the second one, plus root 3i is for the first solution. Two solutions are there. So you can try to do this equation also. All of these, let there be fractions, no problem. I'm just showing. Now let's see some properties of this iota, the imaginary number. Square root of minus 1 is not real. That we have already noticed. It's not real number. Now, if you square root of minus 1 denoted as I, if you square this I, you will be actually squaring minus root of minus 1 square. Root of minus 1 square will be minus 1. So we can say I square will always be minus 1. Very important to know. I is square root of minus 1, whereas when you square the I, you get this minus 1 as the answer. Quite obvious. Now let's see what happens if you take I cube. I cube. I cube can be written as I square into I. But I square is already minus 1 into I. That is equal to minus I. So I cube is equal to minus I. And I raised to the power 4. What happens now? I raised to the power 4 can be written as I square into I square. First I square is minus 1. Second I square is also minus 1. When you multiply minus 1 and minus 1, the answer will be plus 1. So I raised to the power 4 will be plus 1. Now, higher powers we are going to calculate, like I raised to the power 5. Of course, it's easiest to write it as I raised to the power 4 into I. Power 5 is bifurcated into power 4 and 1, because I raised to the power 4 is equal to 1. So this can be written as 1 into I. 1 into I is I. Then, what about I raised to the power 6? Again, I am going to take the help of I raised to the power 4. Just because I raised to the power 4 value is just 1. That will be the easiest calculation. So here what happens? This is 1 and I square is minus 1. It was done earlier. I square is minus 1. So using both of them we get 1 into minus 1. The answer is minus 1. I cube. I raised to the power 7 can be written as I cube into I raised to the power 4. Doing similar way, I raised to the power 3. I cube is already being calculated as minus I. Use it here, and I raised to the power 4 is equal to 1. Using both together, we get I raised to the power 7 is minus I. Now, what about I raised to the power 8? It can be written as I raised to 4 into I raised to 4. Both are plus 1. So 1 into 1, that is 1. Now you can notice one interesting fact. I square, I cube and I raised to the power 4. First 4 powers, they are simply getting repeated in the same order for 5, 6, 7, 8 powers. Yes, it's interesting. See, I minus 1 minus I and 1. Again I minus 1 minus I and 1. That means if you go ahead, I raised to the power 9. I raised to the power 9 can be written as I raised to 8 into I. I raised to the power 8 is 1. So we get I raised to the power 4 to whole square into 1, and therefore it is I itself. Similarly, systematically going ahead, we will notice that this cycle of 4 values will get repeated for the next 4. So, multiple of 4, taking that as power, we can calculate the value of I raised to any power. Now let's do one individual question. I raised to power 50. If you want to find 50, see, is 50 a multiple of 4? No. 50 is last multiple of 4 is 48. 4 into 12. 12 fours are 48, and there is 2 left, isn't it? So we can write it as I raised to the power 4 to the power 12. Why that 12? 12 fours are 48 is this power. and I square. I square is minus 1, already done earlier. So wherever this I raised to power 4 comes, that is 1. 1 raised to the power 12 into minus 1, because I square is minus 1. It was done in the beginning itself. So as you multiply, you get the answer minus 1. Similarly, any other power, we can take the help of multiple of 4 number. So power 25 means I would prefer to go by 24 and 1. 24 plus 1 is 25. So I raised to power 4 raised to the power 6 into I. So the answer is I. Any other power can be calculated like this. I raised to the power any other number. Now, a number in the form a plus ib is called a complex number, where a and b are real numbers and I is square root of minus 1. This is the definition of complex number. Real part and imaginary part. The coefficient where I is present, that will be imaginary part, and the term without the imaginary term, that is called real part. Now, if a complex number is named a plus ib is named z. See, the z is only name of that number. If z is a plus ib, real part of z is a, imaginary part of z is b. This is symbolic way of expressing it. Now, if two complex numbers are equal, when do we say two complex numbers are equal? When real part is equal to real part as well as imaginary part is equal to imaginary part. Only then the two complex numbers are called equal. Very important to know, though it looks very obvious. Now, if we take two complex numbers z1 and z2, one is a plus ib, the other is c plus id. And we are going to see if two complex numbers, these two are equal, we can then say this real part must have been equal to this real part, that is a equal to c. Also the imaginary part both also should be equal. So this is what the equality of two complex numbers. Now moving ahead, we will take two complex numbers. One complex number is a plus ib and the other is a minus ib. Only the imaginary part is written negative, in the sense opposite side. So we say this new one what you have written is conjugate of the original one, and we denote conjugate z conjugate. And of course, if you find the conjugate once more. Next, we are going to see algebra of complex numbers. What is algebra? Algebraic operations are addition, subtraction, multiplication, and division. Let's see how we perform them. Two complex numbers, z1 and z2 I have taken here. z1 is the name of first complex number. The number is a plus ib. z2 is the name of second complex number I have taken. The number is z plus id. Then z1 plus z2 if you want to add, then the procedure is this: you just make the real part of the sum as the sum of the real parts, a plus c, that makes the real part, and the imaginary part ib and id added, taken I common, b plus d. That's all. It's very straightforward way getting the sum of two complex numbers, real part and real part added to get the real part of the complex number, and imaginary part and imaginary part added. Let's do a numerical. Yes, z1 is 5 plus 7i and z2 is 4 plus 3i. Two complex numbers. Example I've taken. Let's see what will be the z1 plus z2. The result is supposed to be a complex number. Now, whose real part will be the sum of the real parts, 5 plus 4. 5 plus 4 is 9.
plus. Now the imaginary part would be the sum of the imaginary parts. 7i plus 3i is 10i. So 7 plus 3i, I taken common, makes it 10i. So we got the sum of the two complex numbers. That's all. Okay. Now its answer 9 plus 10, 10i. That's it. Now let's see how we perform the subtraction. Subtraction also done in a very similar way. Real part minus real part forms the real part of the subtraction. C, A minus C. Instead of A plus C, now it is A minus C. And why is it so? Because you see, Z1 is A plus IB, and then you are subtracting C plus ID. So if you open the bracket also, you can see this is A plus IB minus C minus ID. And you just take the like terms. A and minus C are real. Put them together. A minus C. That's how we got A minus C as the real part. Now you look at the other two terms, IB minus ID. So I'm taking a plus I common, so we can write B minus D inside. This is how we perform subtraction of two complex numbers, and you're going to do a numerical. Let's do the same numerical. Z1 and Z2 have already taken now. So Z1 minus Z2 we are doing. Z1 minus Z2 is 5 minus 4. 5 real part minus real part. 5 minus 4, that is 1. That is a real part of the subtraction. Then 7i minus 3i will be 4i. So we got Z1 minus Z2 also. Then next is, if Z is a complex number A plus IB, Z conjugate is A minus IB. This was mentioned earlier also. Now, if you add the two complex numbers, when they are conjugate to each other, if we are adding both of them, that is a complex number plus its own conjugate, when you add, what happens? Real part plus real part is A plus A. That becomes 2A. Plus, now we are heading for IB and minus IB to be added. What is IB plus minus IB? That will be 0. So there is no imaginary part. Hence, we say to a complex number and its own conjugate, when you are adding them, you get 2A, which is denoted as twice of real part of Z. Real part of Z was A. So the answer is here 2A. So twice of real part of Z we say. Next we will see how we do the product of two complex numbers. Two complex numbers A plus IB and C plus ID. Z1 into Z2. How to perform? I'm just going to write the two complex number in the multiplication form here. Yeah. Z1 is this, Z2 is this. Now simply apply the distributive property. So we have AC plus A into ID, then I into BC plus I into IB into ID. So in the last term, there is something special. AC plus I into AD, simple distributive property. The fourth term gives you I square, because I is there with this one also, I is there with this also. So when you multiply, we get I square BD. And we have already noticed I square is minus 1. Therefore, in the next step, we will rewrite that I square as minus 1. Minus 1 into BD. So the term is minus BD. Now you notice that in this fourth term there is no I, because of which we can join these two together as real part. Whereas the middle two terms had I in it, that I is being taken common, this will be the imaginary part. So bring together that real part and real part, AC minus BD, and then write the imaginary part taking I common. This is it. So the multiplication of two complex numbers while doing, you are actually doing distributive property, simple distributive property. In addition to that, use I square as minus 1 and nothing else. So we can say real part of the product, real part of Z1, Z2 is equal to AC minus BD, AC minus BD. And imaginary part is AD plus BC. Next, do a numerical example. So 3 plus 5i and 4 plus 3i, let's multiply. Simple distributive property. 3 4s are 12. Then 3 into 3, 3 3s are 9i. Then 5 4s are 20i. And the fourth term, I square term, 5 3s are 15i square. So 15i square will then be written as minus 15. This is the only extra thing you have to remember. Rest everything is normal. So that minus 15, since it has lost this I in it, this will be treated as a real part now. Real term. So minus 15 and 12 together makes it minus 3. And 9 plus 20, 29i. So the multiplication is performed like this. Now, in case we need to divide z1 upon z2, okay, first you write in the rational form, in the quotient form you write, and to complete this division, what we do is we will multiply and divide by the conjugate of the denominator. So if 4 plus 3i is the denominator, multiply and divide by 4 minus 3i. The denominator's conjugate, same you multiply in the numerator also to balance it. And then perform the multiplications in the numerator as well as in the denominator. Multiply and divide by the conjugate, and now we are going to do the multiplication of the numerator. Multiply these two, that will be the numerator. Multiply these two, that will be the denominator. Let's see what happens now. Interestingly, the denominator 4 plus 3i into 4 minus 3i. If you apply distributive property or if you apply a plus b into a minus b identity, it will be in the form a square minus b square. A square is 4 square minus 3i square. 3i square means that is 9i square. 9i square. There is a minus already here. So 16 minus 9i square, that is 16 minus, I square is minus, so minus 9. 16 minus minus 9, that is 16 plus 9, that is 25. A real number will be the denominator. So same time you need to multiply the numerator factors also. So the steps are coming. 16 minus 9i square, applying a square minus b square identity. Then I square is minus 1, so it is minus 9. Minus minus 9 makes it plus 9. So 25 in the denominator. By the time the multiplication was done in the numerator also, distributive property. 3 4s are 12, 3 into minus 3 minus 9i, etc. So right now you are at a step where the denominator is a real number. Numerator is complex. So here what we do is, now we write it as 27 by 25 is the real part plus 11 upon 25 into I. This is the imaginary part. So whenever you perform algebraic operations, the net result is supposed to be written in the form A plus IB form. That is called standard form. A is the real part. So this 25 is given to 27 numerator as well as to 11. So 11 by 25 is the B. So answer always is supposed to be left in the form A plus IB, which means the denominator has to be separately given. Now real part of Z1 upon Z2 here. is 27 by 25. Imaginary part of this Z1 by Z2 is 11 by 25. Now, as we have learned algebraic operations on complex numbers, we will be able to do the questions based on them. Questions in this exercise. Express each of the complex number given in exercise 1 to 10 in the form a plus ib. A plus ib is called standard form. Let's see how we express it. The question number 1. Question number 1. Here is a imaginary number. Here is an imaginary number. We need to multiply. Now you can see there is one I in the first one. There is an I in the second one. So I into I. Let's write that I square. And the remaining numbers let's multiply. 5 into minus 3 upon 5. So obviously this 5 get cancelled and there is a minus 3 only left, and I square is another minus 1. I square is minus 1. So the answer is minus 3 into minus 1, that is plus 3 is the answer. But don't leave it like this, because you are told the answer should be written in a plus ib form. Notice that there is no imaginary part. This number is a purely real number. Still we should write it as 3 plus 0i. No imaginary term. Only then this can be called the standard form, a plus ib form. So the steps are here. Simple numerical calculation, where you have to apply minus 1 square, minus I square is minus 1. So this is it. Now it's purely real number, so write it as 3 plus 0i, real part and imaginary part. Question number 2. I raised to the power 9 plus I raised to the power 19. I raised to the power 9, I would write it as I raised to the power 8 into I. 8 plus 1 is 9 power. I raised to the power 9 is written as I raised to the power 8 and then into I. Similarly, I raised to the power 19, I'm using the multiple of 4 actually, no? So 8 is multiple of 4, 16 is multiple of 4. For 19, it is better to write I raised to 16 and I cube. Then I raised to 8 is I raised to the power 4 whole square. I raised to the power 4 is 1. Therefore, 1 square. So here it will be 1 into I plus. This will also be 1 because that is 1 raised to the power 4 into I square. Give I square value also. I square value is minus 1. So I square into I, that is minus I. So the first term I raised to 9 goes to plus I and the other one goes to minus I. So the answer is 0. This is it. Next question. I raised to power minus 39. Due to the power negative, we can write it as 1 upon, but I prefer to write it as I raised to power minus 40 plus 1. It's going to be easier. Minus 40 is multiple of 4. So I raised to power minus 10 into raised to the power I raised to power minus 4 raised to the power 10. I raised to power 4 is 1. 1 raised to the power 10 is 1. So answer is I. It is purely imaginary number. So to write the standard form, you have to write 0 plus 1i. This is the standard form.